going to have a webinar, which is an introduction to the oil well directional drilling. When we talk about oil well directional drilling, we're going to touch up some other equipment that are used in conjunction with directional tools, including the MWD, currently the MWD and LWD, which is measurements while drilling logging tools and logging while drilling tools. I would like to welcome all of you to this webinar, and I would ask you to please, by the end of the webinar, if you have questions, just state it, and I will try to answer some questions after the webinar. And also, you need to go to the chat. There's going to be a link in the chat. So you need to actually go to this link, evaluate the webinar, which will send your information to the to our office, and so they can issue a certificate of attendance for you. Please make sure to actually communicate through the link, so the certificate would be issued on your name. All right, after this introduction about the webinar itself, so I would like to introduce myself. My name is Adil Abdelaziz. I'm the President and CEO for Sahara Training and Consulting and Petroleum Services. Today, I would give you an overview, as I said, for directional drilling, MWD, and most importantly, the amazing development of these tools, which I have witnessed over 40 years being around, running mud logging initially for the first 2 or 3 years, and then MWD and survey and pressure survey tools, and finally LWD, logging while drilling tools in different positions. And I've served in the oil field in different positions. I've been actually field engineer as usually to start with, and I've coordinated the operations for different services. I've been a manager and instructor with Halliburton University in Houston, in addition to other managerial positions. 40 years mainly with Halliburton, and I joined Sahara last year. I've been with them for 1 year right now. As an overview for what we're talking about, we're going to actually discuss the industry today, why we use directional drilling. We're going to have a brief visit to the rig, just know the major components if you don't know. And also, we'll discuss why we should use, or we have to use, directional drilling and logging and measurements while drilling tools. A brief information about how these tools are working, and how we set up these tools at the rig site. Just a very fast glimpse of what we actually do at the rig site. All right, يا جماعة. أنا بتكلم mainly يا جماعة بالإنجليزي على أساس إن في attendees from different countries with us. So English is a major language in the industry, and I expect that everyone, inshallah, will understand. Okay. Why we use directional drilling? Okay. We use directional drilling because the easy drilling is gone. What we mean by that? The easy drilling is gone. We mean that, all right, the vertical well, or when exploration guy is used to go through the desert and find traces of oil and just set the rig and dig a vertical well over there, these days are gone for good. And the easy reservoirs to find and drill through are not there anymore, all right? So we need to reach the targets and reservoirs from different areas and different angles, and that's why we went to the directional drilling, okay? Simply, we can say that there are many challenges right now, all right, for wellbore profiles and reservoirs that require difficult and more complicated plans to reach these reservoirs. This includes high cost actually of drilling. I mean, using directional tools will actually result in using more complicated and more sophisticated equipment, and that at cost. Also, we use the directional drillings because we got a lot of uncertainties, and economic viability as well. Okay, what we mean by economic viability? We mean that if we drill one vertical well that will go through a reservoir, I will have, for example, if that reservoir is like 10 meters, I will have a production from 10 meters of the reservoir. However, if we drill a horizontal well or an extended reach well, that will help going through the reservoir with distance, sometimes based on the lateral part of the horizontal well, and we're going to discuss that. Okay, simply a horizontal well may give a production equal to 2 or 3 or 4 vertical wells based on actually the area, environment, and geological characteristics. So this is simply why we drill and use directional drilling to drill our wells. How we drill our wells? In order to actually access different reservoirs and different area, we use different types of rigs. Simply, we use land rigs. When we look at it based on the environment, if we're going to drilling in land, we use land rigs. If we're going to drilling in offshore in the waters, we'll use offshore wells. Do all rigs are the same? Of course not, all right? Land rigs would vary on the size. When I mean on the size, then I mean relying on the depths of the well that we actually going to drill. All right, so I may have a rig with bowers and efficiency to drill up to 10,000 feet, or a rig that will actually go down, can help me to go down to 25 or 30,000 feet. All right, so the type of the land rig will depend on what we actually need to drill. all right? When we go offshore, things are different. The type of the rig will rely on and depend on the water depths. We could drill wells in shallow or medium or deep or very deep waters. So based on that, if the seafloor is reachable, we can use jack-up rigs like this one. All right, we can use jack-up rigs like this one. And at medium waters, we can actually, we use what we call semi-sub rigs, semi-submersible rigs. And in the deep and very deep waters, we use floaters. We use a drill ship, and a drill ship that we actually is a ship with a rig on it. So we use different rigs based on a different environment. Either we drill in land desert, or plantations, or actually we drill offshore with different water depths. Okay, based on that, you expect, of course, all right, the daily rate, the rental of the rig is going to be changing. Of course, you're not going to have a land rig with normal capabilities with the same price as you go to the drill ship rig or a semi-sub rig. So the daily rate of the rig, and also we should consider the supporting companies that lives in the rig. At the rig side, if you don't know, there would be the rig crew and the rig management, and also the customer representative, and the companies like Directional Drilling Company, LMWD Company, and so on. This is while drilling. And then while the completion and production people specialized in that will be on the rig side. All right, so rig daily rate would vary. It could be from $10 to $50,000 per day, or sometimes actually the $20,000 is going to be the rate per hour for more sophisticated semi-sub or drill ship. So the daily rate and cost for deep water drilling could be reached up to $500,000 per day. So that's why we should have a well-planned, engineered wells, so we actually can reduce the cost. No time for problem, no time for actually, no time to waste, because 1 second costs thousands of dollars sometimes. All right, what are the key challenges in drilling wells? The challenges that we have in drilling wells would include actually how to identify the wellbore position. We need in a well plan to know where to reach the target. We need actually to plan sometimes to avoid certain areas like depleted areas, and high pressure area, fractured area, faulted areas. So that should be in the well plan. We also, when we plan, as I'm going to show you later, we need to maintain a smooth well profile. This is with regarding to identifying the wellbore position. What about the decision making? Oh, the geologist. All right, just as the well plan being actually engineered before the start, the geologist should actually would know from the nearby wells where we're going to drill to. They should know the prospective formations. They should actually work with the drilling engineers to have the well plan to be actually reach the optimum recovery position within the reservoir. We should have more information from the surrounding area to reduce the uncertainties. And all the plans should work on save the time. Drilling guys at the rig site and the drilling people usually would look for faster drilling. Okay, we need to drill. Okay, drill, but while drilling, you actually need to maintain strict standard in safety and environment. You need to drill a control. You need to have a controlled drilling situation, and this is all reachable. Then we get to the point that if we're gonna see all this or satisfy and overcome all these challenges, we need to use directional drilling tools plus measurements and logging while drilling tools that will help the on-site specialists, whether a geologist or the drilling people, and of course the people in the town, all right, to make real-time, do real-time decision. It just right now we geosteer the well. We see where the well is going through, all right, and we can, from the surface, we can correct the position of the well to run through the reservoir, all right, for the whole lateral section. It's not only drill through the reservoir area to produce oil. No, we can actually position the well within the reservoir to have the minimum water, or to have actually the most or the highest recovery. So these tools are just like a camera or eyes for us at the surface that will tell us where we are going, and if we have issues and problem, we can actually correct it right away. It's not right away. I mean, we take the decision, and if, for example, I'm getting out of the reservoir going up, then I'll point my equipment, as I'm going to show you, my tools, directional tools, to go down and return back to the, or from the beginning, maintain our lateral section through the reservoir all the time for the best recovery. Okay. That was our initial introduction, all right? Then next, what actually accommodate all this equipment and how we drill the well? This is the rig, all right? And when we go to the rig, and in general or generally actually identify the rig component, the rig has three major components, all right? Hoisting equipment, circulating equipment, and rotating equipment, all right? Hoisting equipment, just like the elevator, I mean, what carried the drill pipes, the drill string, and run with the drill string to the hole, inside the hole, all right? And we get the section where the elevators and we have a lot of other equipment, just like to carry all the string inside the hole. Okay, circulating equipment that will help us to circulate through the drill string. We pump the mud through the drill string and lift actually the cuttings that is being drilled from the formation to the surface. We circulate the mud, which is the drilling fluid, at high pressures. We actually need to control the pressure. The whole well needs to be controlled, all right? And these circulating fluids will not only carry the drilling cuttings, but also help in lubricating the bed and cool the string, and also leave what we call a mud cake on the side of the well that maintain actually the well stability. We also have rotation equipment that will help rotating the drill string. That's simply, anyway, I'm just talking in general about what rig equipment or component that will help us do the job we are looking for, which is drill a directional well. The rig is above the surface. It's underground, where we have plenty of drill pipes. Drill pipes, it just like this is the string that would connect with our jury, the downhole jury, which is actually what we call bottom hole assembly plus measurement and logging tools and direction drilling tools, including motors, rotary steerable, and we'll get to that. Don't actually, we'll talk about all that. Okay, so we generally have a lot or plenty of drill pipes that we use to drill and go to the depths we want to. Down near the bottom, we also have among the bottom hole assembly drill collars, and I'll show you soon what is the drill collars, which is heavier pipes that will give me more weight, so will help me to put weight on the drilling bed, and I can, with rotation, I can drill through. And then the bottom hole assembly. The bottom hole assembly mainly would be drill collars, stabilizers, and also our juries, downhole juries, and that costs sometimes millions of dollars. But actually will do the job. It's going to be my eyes down there, right? The motor, MWD, LWD, and whatever controlling the well direction and send me more information about the formation. And at the end, very end, or is the bed, which is the tool that will drill through. I hope everything is going okay so far. I'm not going so fast, but I may take more time, so let's see. Okay, let's talk very fast about the drilling components. Drill bits, as you may know, actually would have different types of bits. The normal, or the bits that we use to drill, to use for drilling initially, are the rotor bits, and are the rotor bits, which could have an insert, 3 cones, all right, with either mill tools or actually insert buttons or tools buttons, as you can see over here. Beside the normal roller bits that have 3 rolling cones, all right, we have the BDC bit. BDC bits, just like the this one. BDC is more solid, more expensive I got actually buttons, most of timer composed of manufactured or artificial diamond, and imberge bit, as you can see, with different shape and design. All these bits actually are designed based on the formations that we're going to drill through, and also the tools that you're going to be used with. All right. So these bits are behind this bit is complicated and excellent engineering ideas that has been derived by different companies like Halliburton Security, DBS, Smith, and Reed, and many other companies. And also the bits comes in different sizes depending on where we are. The surface, we can use 26 inch, and then intermediate hole 17.5 or 12.5, or going down from 8.5. I mean, it's depending on where we're going to drill. And we also actually, we see that we actually having different hole section to go through to reach our reservoir. Okay, next. We said we have plenty of drill pipes, right? And drill pipe is just steel drill pipes, mainly 5-inch drill pipes if you are drilling surface, intermediate, and 12.25, 8.5. And when we go to 6-inch holes, when we go to smaller holes, we use 3.5 inch drill pipes, right? So drill pipes, a joint is typically around 30 feet long, all right? As I said, different diameters based on the whole section, connected to each other. I mean, every joint connected to the other joint. They got bins, all right, threaded bins and boxes, and got a specific torque to actually connect them to drill pipes. Remember, we talked about drill collars, right? Some of the drill collars are a spiral like this, and some of the drill collars are not. And what is the best? It's better to be a spiral like this. Why? With hole problems like stacking, of course, I need minimum contact area with the hole, with the well side, all right? So it's better to have a spiral drill collars. Spiral drill collars. Why we use the drill collars? Drill collars give us the weight downhole. It's heavier pipe, more steel in it, that give me more weight actually, so I can push the bit down and put more weight on the bit. It also will give a stiffness to the string, all right? Also, drill collars got threaded connection, bin and boxes, all right? It comes in different sizes as well based on hole section. It could be 8-inch, 6.75, or even a small, as we've agreed, depending on the hole size over there, okay? So drill collars. We mentioned drill pipes at the top, drill collars, and then that we also talked about the bit. Now we are missing, okay, our juries, the MWD, LWD tools, and this is what comes. To drill the well, we not just go and drill one hole all the way down. No, this is not happening. We drill the well in sections, in stages. Drilling is done in stages, all right? Afterward, we drill certain section. We start from the surface with holes like 36-inch. We can dry pipe if it's offshore, friable or loose seabed, and or actually land rigs. We run surface pipes for the land, for example, to cover the underground water. And this is what we call casing. We drill the hole and we cover it with the casing. All right, we cover the hole with casing, so the hole is not going to collapse. And also, like at the surface, we cemented it to prevent communication with the underground water or polluting underground water. Okay, if we drill very long hole without casing, what will happen? The hole is going to be collapsed. We'll have a lot of problems. The formation is going to be fractured. We may end up actually having influx from a high pressure zones. So we use the casing actually to protect our underground water, to protect our hole, to isolate zones with different formation pressures. Accordingly, as I said, casing would come in different sizes, as you can see, from 26-inch or sometimes 36-inch pipes to 6-inch and even less more. Casing, when run from bottom to the surface, is called casing, and sometimes they hang the casing on the bottom of the casing that has been run before, and in this case we call it liner and not this. All right, let me show you this cartoon video, or that will actually show you the rig site and explain a bit about all what I have been talking. Enjoy.
After the well site has been carefully prepared to meet environmental, health, and safety standards, drilling can begin. This is an intricate operation requiring a well-planned infrastructure. A variety of processes and expert, well-trained specialists are used to bring natural gas to the surface. Chesapeake works with these experts during every aspect of the project, while strictly adhering to all individual state regulations. During the drilling process, the rig is in constant operation 24 hours a day, 7 days a week, for approximately 21 to 28 days. As an added precaution in some areas, a protective mat covers 2/3 of the pad site. Utilizing heavy-duty industrial-strength drill bits, a typical well is drilled in several stages, starting with a large diameter drill bit and then successively smaller drill bits as the drilling is advanced. After drilling each portion of the well, nested steel protective casing is cemented into place. This will protect groundwater and maintain the integrity of the well. Initially, and prior to moving in the drilling rig, a large diameter hole is drilled for the first 50 to 80 feet. Conductor casing is then cemented into place, stabilizing the ground around the drilling rig and wellhead, and isolating the well from most private water wells. In the Marcellus area, the freshwater zone extends to approximately 800 feet below ground. The freshwater zone consists of porous sandstone and rock stratus containing water within the pore space of the rock. Chesapeake utilizes air drilling until the hole is advanced to an average of 100 to 200 feet below the base of the freshwater zone. This provides added protection to the freshwater zone. A series of compressors and boosters generate the air that is used to lift the rock cuttings and fresh water into steel bins. The rock cuttings are then disposed of within state guidelines and permits. The drilling equipment is retracted to the surface and stored for the second stage of drilling. To protect the integrity of the hole and to protect the surrounding deep freshwater zone, a second layer of steel casing, called surface casing, is installed and cemented inside the newly drilled hole and conductor casing. Cement is pumped down through the surface casing and up along the sides of the well to provide a proper seal. This completely isolates the well from the deepest of private or municipal water wells. A blowout preventer is installed after the surface casing has been cemented. The blowout preventer is a series of high-pressure safety valves and seals attached to the top of the casing to control well pressure and prevent surface releases. Next, a small drilling assembly is passed down through the surface casing. At the bottom of the casing, the bit drills through the float equipment in cement, continuing its journey to the natural gas target area, as deep as 8,000 feet below the surface. The drilling method employed below the surface casing uses drilling mud, which is a non-hazardous mixture based on bentonite clay or synthetic thickeners. In addition to lifting the rock cuttings out of the hole, drilling mud also helps to stabilize the hole, cool the drill bit, and control downhole pressure. A few hundred feet above the target shale, the drilling assembly comes to a stop. The entire string is retracted to the surface to adjust the drilling assembly and install a special drilling tool. This tool allows Chesapeake to gradually turn the drill bit until a horizontal plane is reached. The remainder of the well is drilled in this horizontal plane while in contact with the gas-producing shale. Drilling continues horizontally through the shale at lengths greater than 4,000 feet from the point where it entered the formation. Once drilling is completed, the equipment is retracted to the surface. Then, a smaller diameter casing, called production casing, is installed throughout the total length of the well. The production casing is cemented and secured in place by pumping cement down through the end of the casing. Depending on regional geologic conditions, the cement is pumped around the outside casing wall to approximately 2,500 feet above the producing shale formation or to the surface. The cement creates a seal to ensure that formation fluids can only be produced via the production casing. After each layer of casing is installed, the well is pressure tested to ensure its integrity for continued drilling. A cross-section of the well below surface reveals several protective layers: cement, conductor casing, cement, surface casing, drilling mud, production casing, and then production tubing through which the produced gas and water will flow. 7 layers of protection. Horizontal drilling offers many advantages when compared to vertical drilling. Since horizontal wells contact more of the gas-producing shale, fewer wells are needed to optimally develop a gas field. Multiple wells can be drilled from the same pad sites. For example, development of a 1,280-acre tract of land using conventional vertical drilling techniques could require as many as 32 vertical wells, with each having its own pad site. However, one multi-well pad site with horizontal wells can effectively recover the same natural gas reserves from the 1,280-acre tract of land while reducing the overall surface disturbance by 90%.
All right, so that was the story, all right, the whole story of drilling well in a few minutes. But unfortunately, this is not easy as we're telling a story. It requires real hard work. All right, what we should have to drill such a horizontal or extended or reach or deviated well? We should have directional drilling tools to direct the well bore. Should have measurements while drilling tools, and these measurements while drilling tools would give me the properties of the wellbore conditions, including inclination, azimuth, pressure, tool face, all right, while the drilling is progressed through the well. So measurements while drilling tools would have directional sensors and telemetry. What is telemetry? Telemetry is, I mean, if we have sensors downhole that will give me information, I would need this information to be sent to the surface, all right, to know such an information, interpret it. And this is what the telemetry or pulsing system will do, all right? And directional sensors and telemetry, usually known as MWD. Also, MWD could have what we call drilling efficiency sensors. Drilling efficiency sensors, these are sensors that will help in drilling with more efficient, drilling more efficiently, and actually overcome the problems. This including vibration sensors, pressure downhole sensors, many other sensors, torque sensors, drilling torque sensors, and so on. Also, this juries or advanced equipment include logging while drilling tools, which will measure the formation properties while drilling, and that would include plenty of information, formation evaluation sensors, as we're going to discuss. All right, so downhole directional drilling and measurement while drilling tool, the string would actually include, if we go from the bottom, would have a bit, depending on Bdc bit, Emberge bit, whatever bit is being identified as suitable. And sometimes above the bit is what they call at bit directional sensors. The motor, of course, excuse me, I've been with Halliburton and Sperry for over 40 years. So it just happened that my example comes from Halliburton, all right? So the motor or rotary steerable system, this is just a symbol, it's not exactly the same tool as we thought. And also on the top of the motor, right away will come the directional sensor. Why? Because we need to know the directional information as close as it should be to the bit. After the directional sensor, and as I said, sometimes we have a sensor near the bit to give me directional information that will be sent to the telemetry above there, above the directional sensor. And on the top of that, we may have different formation evaluation sensors or drilling efficiency sensors. As you can see here, we may have density, neutron, sonic, caliber, gamma ray, right, vibration sensors, resistivity sensor tools. These are logging tools, all right, and also downhole to control all these sensors, very advanced sensor. There should be a downhole computer and a pulsar to server telemetry system, which is a pulsar downhole computer and the pulsar to send the tools to the sensor, to the sensors. All right. All right. So why would they that? I mean, the operator would pay so much money in getting such very expensive directional and LMWD tools. Why? I mean, to reach the unreachable. What I mean by that, to reach the unreachable, actually, to drill a vertical well, what you can do is just go with a rig that would handle such a depth and have drill pipes, bottom hole assembly of drill collars and stabilizer and a bit, and go drill vertical well, all right? But the vertical well, as I said, is not going to give you, and as we have heard through the clip, all right, is the production of the vertical well is going to be limited when it's compared to the other wells. So yes, we drill such a deviated or horizontal or whatever directional well to attain more production, but also there are difficult situations like we can drill from one location multiple wells, right, from one offshore structure, what we call offshore platform. You see that we can have, for example, 20 slots to to drill 20 wells that goes in different direction, whether to the same reservoir as you can see here, or different reservoirs. All right. What if we have wells that is uncontrolled, exploded, and we have fire, just like what happened at Kuwait and in Iraq or many other areas? These things happen. How to control such a well if the surface equipment failed? We drill, we go far a bit from the well, and we drill what we call relief well. That relief well goes into the uncontrolled well, and we start to control it and actually shut it off. Okay, vertical wells. We may have old vertical wells that is drilled, and original well bus is not producing anymore. We can actually go and with a directional, correct the well directional and go vertical again in a different reservoir. Site tracking. We may have existing wells, and we can do another branches through what we call site tracking to reach another area of the reservoir or a different reservoir. So as you can see, there's so many tricks there, all right? Okay, to accurately reach the required target, which is the reservoir, all right? We should have what we know as a well planning software. This well planning that will be run by a well planner. It could be a geologist, it could be a drilling engineer, actually will give us a precise well plan that will help the direction driller to reach the required target. Okay, what well planning programs do? They usually design the well banks to reach the target and to satisfy technical requirements. The most important is actually to avoid the collisions, particularly at the surface or sometimes downhole when area is very crowded with wells, to avoid collision with nearby wells, which is very important stage. Okay, so this is well planning. Well planning, as I said, help us to have a precise well pass, and we hit the target, the defined target by the operator. Okay, so well planning and also following the plan, all right? Following the well plan by the direction driller using the direction drilling equipment will help us to reach the target, not to actually go with that anywhere and nowhere. This is when the direction, and imagine what is going to happen to the direction drill if we did that. Okay, this is still sometimes. Okay, why we use the LMWD, directional survey? Okay, so we use the directional survey equipment to know where we're going downhole, all right? How to know where we're going downhole? We should have the inclination, the angle, right? Which is the well pass angle from vertical. And we need to have the direction or the azimuth. Where is the well bore directional wise from true north, all right? Or sometimes at the surface magnetic north. I mean, usually we need to know where we are from the north. And how actually we know or we build or drop angle downhole? A third information need to be there, which is the tool face. The tool face is actually what helps us to orient the bit, all right? The tool face is where the bit at with regards to the wellbore high side. All right. So the tool face is telling me I'm going toward 20, for example, southeast, or I'm going toward exact north or toward exact south, and so on. All right. So the tool face is the tool that will help the directional driller to orient his tool and get to the target. Okay. Some survey definitions you may be familiar with, which is rig Kelly bushing. Kelly bushing is very much the, we can simply say where is the rig floor is, all right? And Kelly bushing is referred to the Kelly. Kelly is a tool in symbol in normal rig that we use to rotate and drill through. All right, so this is like, say, the rig floor. Kickoff point is where we start to deviate from vertical, and then build section. Build section is the section that we've been building angle in, at the well side, at the well bath. And end of build, when we stop building, all right, and we go actually with hold angle, that's what we call tangent or holding angle. Say we've reached it, for example, here, 45 degree, and we've been holding 45 all the way up to this point. Then we start, we need to drop. So drop section is where we start to drop the angle to reach the target. Departure is how far the well bore away from vertical. Depth is depth, of course. There's some definition, simple, all right, definition for the survey. All right. Well baths actually could be drawn like this with a section view, all right, section view, or would be drawn by coordinating a plan view to show the orientation. In this type of well, because we drilled, we kicked from vertical real fast here, we know as short radius. All right, we consider this the kickoff point. Then we build very fast build, which this short radius well, end of radius curve. All right, and this section is the lateral section going through. Usually, lateral section would be through within the reservoir. All right. Now we get to the point how directional tools are worked, how we deflect the well, all right? How we actually get such a complicated plan downhole done, completed. How we reach a point that is sometimes very few kilometers away from the rig site, and with big depths downhole. Okay, directional tools will help us to go there and to reach the planned target. All right. What we use to deflect the string downhole, we use what we know as web stocks. Rotary bottom hole assembly. We use motors, and we use rotary steerable systems. As I said, right now we use all these based on the situation, based on the couplant cost, and all right, and so on. Okay, when we talk about web stock is a wedge like this, metal wedge, all right, and this is one of the earliest tools we use to drill. Web stock is set downhole using directional tool as well, because it's going to be set in a specific direction, and this actually show you how the web stock is set inside casing, and the primary use for web stock is to sidetrack. We mentioned some of the uses for directional tools is to sidetrack. So how to sidetrack using this metal wedge is actually we start with a starter mill, a mill that would be able, is kind just like the bit, but it would be able to drill through the metal, all right, to deflect or to open a window through the casing. Would have two trips. We do the starter mill to start eating through the casing wall, and then we run back with heavier window mill, and on the top of it just water, what we call a watermelon mill, and that actually will drilling through will open the window in the required side and required direction. Opening window would require specific tools, like, because we're drilling inside metal, so would have an interference, magnetic interference. So we use a specific directional sensors like gyros that would not affect by the metal to show where we are while and where the window is going to be drilled. Second deflection method is a rotary bottom hole assembly. What we mean by rotary bottom hole assembly? We mean we actually simply use design the bottom hole assembly from drill collars and stabilizers by placing the stabilizer at different locations. So we can actually build or hold or drop angle. How is that? This is interesting. Yes, it is interesting. We use actually, if we want to build, we use a nearby stabilizer. That is going to be a point to actually rely on it to push the bit when we put weight on it. So for building, you would notice that we will need to have a near bit stabilizer. All right. What else? We can have dropping assembly, and we can have, as I said, a holding assembly. How this assembly looks like. All right. Let me go first for building assemblies. Okay. As you can see here, we got different. You can design your assembly to give you whatever build you require. If you need to have a high build, what do you do? Put 3 colors and between the near bit stabilizer and the second stabilizer. What that means? You will have more bend. When you put weight in here, you will have more bend, so you will push the bit up and build more. All right. And this is another example for just near bit stabilizer and push higher to the top, so you build the angle. Okay, here's another example with 3 stabilizers. So your center point is going to be in here. Okay, and this one, as I said, you play at the direction drill play with the stabilizers and drill collars to show to build the angle he actually requires. need to. All right. Dropping assemblies. When we get to drop assembly, what you can see now, no near bit stabilizer. Why is that? So you actually move the center point, the point that you're gonna rely on when you put the weight. The weight is gonna come on the top of this point, and this bar is gonna bend. But when it's bent, the bit, when this colors is gonna bend, it will go down. And this will actually give very high with 60 feet between the bit and stabilizer, and as we said, no near bit stabilizer. Based on the location of the stabilizer, the dropping is going to be done. Okay. Hold. When you want to hold, what you do? Put more stabilizer and less colors. See that? Four stabilizers, less colors between the stabilizer, and so you can hold the angle as is, very stiff assembly. Okay, we said we may use actually, bottom assembly as deflecting. We initially mentioned with stock, then bottom hole assemblies, configuration, and we can actually use adjustable stabilizer. What do we mean by adjustable stabilizer? A stabilizer that could be adjusted to specific blades. And how that configuration works, we actually would have the bit, and on the top of the bit, we would have an 3/16" or under gauge stabilizer. And then if we need to hold the angle, we will have the adjustable stabilizer would be, as you can see, this is an example. And as I said, the designs of this, the direction driller and well blend would actually use to design all these assemblies. So we can design it in a way with how much under gauge is going to be the adjustable stabilizer or full gauge. So in full gauge is will give dropping. As you can see here, 1 1/4 under gauge from the whole side will be do building and or actually holding when it's only less under gauge. This is how the adjustable stabilizer gauge is. Usually, this is when the pistons are retracted using pressure and weight, string weight would activate the adjustable gauge stabilizer and push the buttons, push actually the buttons up and to the specific stabilizer size that is required. Okay. So mention with the stock, we mentioned bottom hole assemblies, stabilizer and colors, we mentioned adjustable stabilizer. Here we go, we come to the motors, mud motors. And mud motors, I've seen all that, of course. I've been in the field from 1980 to actually maybe 1996. So I've seen things developing real fast. I mean, late 70s, what we used to have, the motor was a straight, the motor was a straight tool, all right? And how we bend the motor, we used to have on the top of the motor what we call a bent sub. A bent sub is a metal sub that is bent based on, has a fixed bend, maybe half a degree, maybe a degree, maybe widgets like this, based on the required build or drop we need to do. So that was early, late 70s, straight motor. Then late 80s, when I joined the oil field, we start to have the MWD, and we have a steerable bent housing motor. The steerable bent housing motor, as I'm going to show you soon, all right, got a bent housing, an area on the motor that you can use at the rig floor. Usually, the motor comes straight, and the direction driller will bend the motor at the rig floor before running in hole using the bent housing. And I will show you this soon. Then later, 1960s and later, and of course we start to have MWD tools, and it was primary tools with limited capabilities, but that was everything was developed. I would like to tell you something. I mean, using a straight motor and bent housing, and we used single shot. I've been actually there. I've been there. During that time, I was actually working as a mud logger, and I remember, okay, where we used to say, the directional driller is going to take a survey. And when the direction driller was going to take a survey, okay, that means time to have a break, 3 hours break or something. He will drop the single shot downhole with a camera that will give a single readings and wait, fish the single shot and to the surface and read the picture to give him direction, azimuth, and full phase, and then use the chains to orient. If he succeeded from the first time to get the survey, use the chains to manually orient the motor and hold it with the chains on the rig floor. And that actually, so single survey. I've seen that. I've been there, my friends. All right, single survey will take maybe 3 hours. I'll tell you, when I was working as an MWD, what was happening, how frequent I was giving surveys. All right, so with MWD, early time, you used to get a tool phase whenever every 1 minute, couple of minutes, and that was good for the direction driller. We used to wait 3 hours or do work for 3 hours to get one survey. But with the current MWD, oh, I mean, we can give, tools can give surveys every second if you want to, but that will overload the direction driller. But we need actually, with direction drilling, we need a direction drilling engineer, a supervisor, not a computer operator, all right? So we have the information, let's create more information, would help me actually to be confident and to place the well at the right position. Okay, so motors right now got a lot of information. It got the MWD, it could have actually near bit or at bit inclination and gamma logs as well for correlation between formations. We may have performance motors and so on. So more tools give us more capabilities. And you gotta excuse me, I'm a Halliburton guy. I've been with Halliburton for a long, long time. So my examples are from my mother country. But it was to say that all equipment are very much rely on the same designs. So you go to Schlumberger, you go to Baker, you go to whatever. I mean, tools are very much rely on the same designs, but different tools, different capabilities based on the company. All right, inside the steerable motor that we have right now, they call it positive displacement BDM motor. Usually the fluid flow drives the inner rotor inside the stator. The outside is the stator, and this is the rotor. I'm not gonna if we're going to talk about motors, we may talk for hours. So I'm just giving you a simple idea. All right, this is meant to be an overview, an introduction to the directional drill. In-depth ones could be attended, and we actually have such in-depth courses to advertise, and we can have more information about it. But I give you the flavor of that business. This is what I meant by this course or webinar. All right. So usually the rotor rotation is transferred. The rotor inside the stator and the motor is transferred to the bit through different parts. All right. And the bit is rotated using the power of the fluids that rotate the rotors inside the stators. And when orienting to build angle, the entire drill string is not rotating. Okay. What we do when we build angle, usually the direction drill orient the bit to the high side. High side could be 90 or less, depending on how much build he is required to do high side. So the amount of angle build is actually would define the high side where the orientation of the bit downhole. Okay. And that is going to be done for a specific interval. And when we do that, we can actually do two methods of drilling. We can actually either slide or rotate. When we slide, we're not rotating the string. We push the bit downhole. The bit is rotated. The bit is rotated by the fluid inside and the power inside the motor. And we just push rotate the bit toward the high side to build the angle based on the interval need to be built. Okay. When we want to hold the angle, we usually rotate the whole string. So when we look at the steerable motor configuration, as I told you, the steerable motor would have a bent housing that would change the direction when sliding the drill string. So the bent housing right now, the bent housing could be manual, or actually that need to be set up and will be fixed at the surface. But right now, what we have the steerable motors that we can actually change the bend of the motor downhole using the mechanism of pressure and weight. Okay, we also use the stabilizers on the motor and to actually define the direction tendency when rotating the drill string. So the stabilizers on the motor will help us to hold the angle or drop, depending on what we need to do. Remember, I told you this is the manual bent housing, and the motor would come straight to the rig side. And what the direction driller is do, he'll bend the motor to the required bend degree, and could be adjusted from 1 to 3 degrees. Usually he break between these two bones and then adjust the angles. For example, this is aligned with this one, so would have 2.98 degree bend. You see that these lines would go align with each other. There are 4 main components for that bent housing, offset housing, splend mander, stator adapter, housing, and adjusting ring. Just more information about it. Okay. How we use the motor, how the motor is gonna do the job for me. As you can see here, remember we said Kelly bushing. This is the Kelly, and this is the bushing of the Kelly. Okay, is an old rig. Okay, using the motor, what we do, as we mentioned, we circulate the mud, so the bit rotate as we took, driven by the A flow inside of the mud inside the drill string. MWD tool downhole would send me tool faces, and now direction driller, instead of having one tool face every 3 hours when he dropped a single shot, now a direction driller can have tool faces every 2 seconds, 1 second. I mean, it's be overloaded with tool faces, thanks to the technology. All right. So the motor, usually we slide to build the angle. The motor is not rotating. It's the mud motor. And when we hold the angle, actually we rotate. We apply weight to the bit when we slide, and the string will continue to build the angle to the desired. Okay. As the well angle built to the what is required, okay, then and no requirement for building more angles, then the string is going to be rotated. Okay. The steerable motor, when we slide, as we said, all right, when we slide, we build the angle or drop based on what we need to do, no rotation for the string from the surface. And when we rotate, usually we rotate the whole string. This drawing will show you that the string is rotated. Okay, the last method of deflection is the rotary steerable. And this is the latest technology. What the rotary steerable will do, will steer the well. We mentioned that the mud motor would need me to do a slide in order to build or drop, and rotate when we need to hold. All right, but with the rotary steerable, no sliding is required. We rotate all the time. All right, and we can change the inclination and direction downhole. So everything is controlled from surface equipment, so it will change the bend of the rotary steerable down. Rotary steerable systems, as I said, it will allow also, I mean, crooked roll could happen with sliding and rotation, dog legs and all that, but rotary steerable systems would help actually drilling a smoother wellbore with less problems. And as I said, tool face adjustment could be done real time. It will actually give me faster rate of penetration, the ROB, compared with the sliding mode. Sliding mode, sometimes you may slide. You may sometimes with some formation drill 1 foot in a couple of hours or more, sometimes faster. Drill string with rotary steerable system maintained in constant rotation, which will improve the whole cleaning and minimize the chance of differential sticking. All right. Designing rotary steerable systems actually depends on the design, depends on 2 ways to perform the directional change. One way is called push the bit, which is how to deflect the bit by pushing tool collar using pads on the opposite direction. So there is a pad in one direction that will push the bit to the upper side and so on. all right? But point the bit is more advanced, deflect the bit off center. And I will show you point the bit. I'm interested in that. This is what most of rotary steerable systems have right now, pointing the bit to the desired direction while the bottom hole assembly is being rotated. And this is, as I said, more recent. Okay, how point the bit, and this is Halliburton G-Pilot, all right, tool diagram. All right, we got an eccentric ring over here that actually will direct the bit toward a specific angle, all right? And rotating inner shaft, in this case, is deflected in center between bearing and the dual eccentric rings, okay? As I said, will tilt. This will result in tilting the ring the bit in opposite direction. And the tool will give you deflection percentage and tool face direction. You get that real time. And also you can change that deflection. So inside the rotary steerable tool, actually the bit is actually deflected, and you can rotate the whole string all the time to build, as I have mentioned. Okay, easy, simple. Everything you see and control from the surface. Finally, we're going to look, I'm sorry we took more time than I have expected. So finally, we need to look at the rig site setup, how the guys set up their equipment at the rig site. And when I know the guys that actually have been working, I've been in the field for over 15 years, doing different jobs, as I told you. So at the rig site, the guys actually will rig up. This is a unit for MWD and direction drilling guys, and usually sit on the side of the at the side of the rig at a safer zone, just like that. Is a rig location, nice location, got a greens and all that. That would be lucky to work there. All right. Okay, what is required? How those guys are rig up or put their sensors to get information. MWD or LWD guys, usually they will have a cabin to work at, as I said. The cabin would be pressurized, okay, and it would be set inside at a location, whether offshore or onshore. Okay, those guys have to rig up depth tracking sensors, all right? And depth tracking sensors could be a draw work encoder. This is the easiest and best one. You actually set it up, I'll show you some, on the draw work. Any slips and hook load, that will show you in the slips, and that would be rigged up on the deadline, and air retriever. This is depth string tracking sensor. All right, pressure sensor to measure the pressure. Remember, we said telemetry depending on the fluid pressure, which is drilling fluids. So we have to rig up a pressure sensor on the actually standby area. Driller display unit. Remember, it should be a display or a screen to show the driller or the information coming from downhole. And they also, at the pumps, they rig up what we call pump stroke counter that filter a noise from the system. All right. Okay, see what I told you? All right, this is a pressure sensor here, what we call pressure transducer, usually installed on the standby here and here, and at the bombs and at the gooseneck. The pressure transducer, this is how we get the signal. How we get the signal. What is the mud pulse telemetry? Usually the tool got a pulsar downhole, either give a negative pulse or just very small, or restrict the pressure to give a negative or a positive pulse inside the drill pipe. And this pulse would be sent to the surface. The pulse, the combination of the pulse or the length between the pulses is actually interpreted at the computer, surface computer, to numbers, values, and so on. Okay, depth tracking system. As I told you, this is the recent one, and of course, I was so happy to see the draw work. Why? Because I'm going to rig it out at the draw works on the rig floor. And in early days, I used to take a depth sensor and set it up on the crown over there. Okay, on the crown. I used to go up to the derrick, up to the top, to the crown, and both rig up my sensor. So you see how easy actually setting up the depth tracking system on the draw works. What is like in the field if you're going to be an MWD or LWD engineer? All right, you got your tools. This is a tool, the formation tester tool, and one of Halliburton colleague there, all right, or any other company. All right, so this is a tool why they actually prepared it to run in a hole, MWD formation tester. And before that, there's a guy inserting the battery inside the tool, or actually doing his measurements for a directional tool, preparing it before running in hole. All right, the guy is doing different activities, testing their tool over here, okay, and their unit and toolbox. And this is actually what I call the MWD pulsar, MWD tools. I've built so many of those, and sometimes we take a break and take pictures. That land rig is good, no problem, okay? But what about offshore? I don't want to scare you, but actually, this is traveling. If you go by boat to the rig, so this is actually how your elevator to the rig, which is the basket. Many times in a windy and whatever, you put your bags over there, and then you actually hang on. It will take you from the boat up to the rig that way. Scary, huh? But you get used to it. All right, that's what I wanted to do. Thank you so much for attending and listening our webinar. I hope you benefited from this. And I remind you again, please fill in the evaluation link, and I'm open. Actually, on time. I should have finished a bit earlier than this to have a chance for more questions, but I'm open for a couple of questions if you'd like. Any questions, gents, ladies? Well, thank you so much. That would be it. I welcome you for other webinars with us. Please follow our advertisement for different free webinars. And as I said, please follow the link to go and actually register so you can get a certificate for that. Thank you. All the best. meet you again in different webinar.